Hello everyone. In this tutorial, I'm going to talk about the fitting for the 3D case. So basically, 3D is more challenging here because the first you don't have a T-graph 3D class. So you can also do it by TS3 class, or another way to use it is to use the tool provided by rule fit namescape here. I will talk about that. Or generally you can use a T-minuet class to do it. And I think in this case, in this demonstration, I will show you the latter one. I mean this case here. So I will demonstrate the bin data. It's very useful, and I will use that later. Also, the rect multi TF1. That means that you have a TF3 function, sorry, TFV object, and kind of wrapping around to make it to a TF1. And also the fitter and the fit result, they all come from the root fit namespace here. Then in a later tutorial, I will show you T-minuet class. The bad thing to use T-minuet is you have to set data to be global. That's one thing you have to really consider about that. If that could somehow accidentally mess up your data if you're not careful enough. Okay, let's go into this script here. So again, I created some data here from Power 1 generate data here. In this case, I create data from TF3, and the formula is kind of sine x, cosine y, and some z, dependent z here, linear function here, has 3 parameters, and the answer is here 1.5 for the first one, and 0.7 for the second one, 0.8 for the third one here. This is the answer, and we want the fit result to be similar to this answer here. So according to this formula, I create data to according to formula and add some noise to this data here. So V stands for value. So you have X and Y and Z, and that's coordinate. You got the value V here. Okay, this is the first part. Should we no difficulty here? Then second part is that just to hold our data set here. In this case, I use bin data class to hold my data. So to use the bin data class is quite easy. Okay, so in this case, I use a constructor that just took first the number of data point and how many variable you have, because we fit 3D in this demonstration, so the variable n is 3 here, and I set the data point is 1000 in this case here. Okay, so I have my bin data object data. Okay, so now the thing is I can use the add method in the bin data class here to add in the one row at a time here. So I loop through how many data point I have. Then the input is kind of coordinate like X and Y and Z, and the output, sorry, the corresponding value is here. I already assign them in the step part 1 here. Okay, so there's nothing different from here, the part 1 and part 2. I just store all the data into my bin data class. Why I do need that? Because later on, I have to use a bin data object to put into uh, our filter, because it take the bin data class as the input. Okay, so far we don't touch anything about the fitting. Now we have to do our fitting setup here. So to fit 3D, you can use TF3 function. So the TF3 I already declared here is in a pointer to TF3, and to do the fit, I have to use a kind of interface called wrap multi TF1 class. To create a class from it, I call it WF. It take the function here, but because we declare is a pointer, so I have to dereference it. So I have a S right here. Then you have function, how many variable in it? Answer is 3. Okay, you declare a wrap around class here. Okay, then you call a filter class to declare a filter. Okay, so this is filter, and I want to use this filter to fit the function f3 through the interface of the wrap multi tf1 here. It's similar to make a tf3 to be a tf1, then do the fit. Okay, so this is probably the new one for you, but it's not that terrible. It just become two-step. So previously we don't have this step, right? But now you just to transform to TF3 to TF1, then put into your filter. And again, for any fitting, you need to set a initial value here. So I set a 111 here. Okay, all right. So now everything is set. You have data, you have formula, then you just code a fit from the filter class here. I mean the root fit filter class here. Okay, you put in the data and you get the return. So if return the fit is good, it return true. Otherwise do nothing. Okay, so now very good. So you already done the hardest part. Then just get the result from it. So you code a filter, your filter object filter, and call the result method. It will return the fit result as the fit result class. Then I call this res here. It's stand for the fit result. Okay. So if you want to print the following stuff, you just code the res print, then use the stand out as a stream out here. Normally you don't need to do this because you can manually code it here. You just need to put the fit result back into your TF3 object F3. Then you can do the same way as you did before for previous tutorial. Get parameter 0, 1, 2 for the first, second, third one. Okay, so there's nothing really very different. The only thing you probably knew is use the wrap multi tf1. Then you put the data into your filter here, then you get result. Still very straightforward. Let's take a look. So let's run the code. Okay, so here are our fit results. Let's see what it looks like compared to our answer. I think it's good. The first one is 1.5, it's 1.4999 something, and 0.7, yes, it's good, and 0.8. So I think this fit is good. Okay, so this is a demonstration of the 3D case fitting via the root fit namespace, and you learn a lot of things like bin data, and this is very useful. I will use it later. And also the wrap multi tf1, also the fitter class and the fit result class. Okay, I hope you enjoyed this tutorial. I will see you later.